Hello and welcome back to the channel. Today we'll be diving into a topic that is becoming more and more poignant: data quality in the age of AI. There are many AI pilots going on in businesses at the moment, and a lot are not working because of underlying data issues. Now, the tech and data governance world often talk about the six dimensions of data quality, the classic rules. But with AI, that framework doesn't appear to be enough anymore, and there's a lot of misunderstanding about data quality impact. Also, what AI can do at the moment. For example, why can't AI know what data is right and what data is wrong? If AI is the engine that's going to drive modern businesses, then data is its fuel. And if you use dirty petrol, it won't just perform badly, it might even crash. So no matter what your background, understanding this is key to becoming a responsible consumer or creator of AI technology. So why are we here? What are our goals for this presentation? Well, firstly, to refresh our understanding of the six dimensions, the foundation for measuring and managing data quality. Second, to clearly show how poor data quality from these six dimensions impacts AI systems, not just traditional databases. There are some subtleties here and technical terms, but I will keep it fairly high level to help understanding. But the important difference here is AI is not just processing data, but it's learning from it and it's making independent decisions. Thirdly, I will introduce three new data quality pillars, crucial dimensions that should be considered when working with machine learning models. And finally, we'll wrap things up with what we've learned and what the future might look like for AI data delivery. So let's start with perhaps the most intuitive dimension, accuracy, and an example. Accuracy is simply, is the data point correct? Does it reflect the real world? For example, if your GPS says you're on one street, but you're actually on another, that's an accuracy problem. So in this example here, if a customer's address is wrong, you might send the package to the wrong place. The impact on AI, however, is that this leads to a flawed data training map. The model learns the wrong rules, treating mistakes as facts. If the AI is trained that New York is where Florida is, every decision it makes based on location will be poisoned, or in other words, corrupted. Next is completeness. This is about having all of the pieces of the puzzle. It's not just about that the data is right, it's that it's all there. For example, a medical record that's incomplete. If it's missing a critical drug dosage, the doctor can't make a good decision. In the world of AI, incompleteness is a huge cause of biased decision making. If the model is missing data for a specific group of people, like a particular age or ethnic demographic, it can't learn how to serve them. It simply learns to ignore, guess, or underserve the missing data group. Consistency means the data looks the same everywhere you look. So, for example, if you buy shoes online, shoe size might be listed as size 42 on one page and size 8 on the other. That's an inconsistency. In this example here, if two different systems call the same person by different names, how can AI know that they are the same person? So the impact on AI is it creates broken AI logic. The model sees the same entity, a customer or a product, as multiple separate things. It can't link their history or preferences, leading to fragmented profiles and bad recommendations. Number four is timeliness, which asks, is the data still relevant now? Data gets stale. For example, a shipping address from 10 years ago might be accurate, but it's not timely if you moved last week. In this example, a weather forecast based on old data is pretty useless. It predicts sunshine when a storm is already hitting. The impact on AI, obviously, is irrelevant predictions. Take, for example, a trading AI using yesterday's stock prices. It'll make the wrong investments today. The model is technically accurate, but it's operating on an outdated reality. Uniqueness means no duplicates, one person, one record. And this is surprisingly hard to enforce. Think about people filling out forms and making a typo in their name or email, creating a new duplicate record. In this example, if a customer has two separate profiles, they might receive two copies of marketing email. The impact on AI is that this leads to undeserved resource allocation. An AI designed to offer a loyalty discount might offer it twice to the same person. An AI calculating inventory, for example, might think you have more product than you actually do, leading to lost sales. And finally, the classic dimension, our final classic dimension is validity. This is about structure and rules. Validity asks, does the data conform to the agreed upon format? If a field requires a date, does it contain a date or does it contain a random word? In this example, a phone number field has letters, and the system designed to call or text that number would crash. The impact on AI, for an AI model, this might cause system failure or errors. The model is expecting a number, gets text, or simply breaks down. It might not be a huge crash, but it can quietly corrupt the model's internal calculations and confidence. So the first 6 dimensions we just discussed are foundational. They ensure your data is clean and usable by any system, and yes, still relevant for AI. But AI and machine learning models are different, so we need more. To reiterate what I said at the start, they don't just process data, they learn from it and make independent decisions on the fly. This responsibility requires us to introduce 3 new crucial dimensions: explainability, fairness, and security. So let's dive into why these are becoming non-negotiable for modern AI. The first new dimension is explainability. Explainability is AI's ability to show its work. When an AI makes a critical decision, we shouldn't just accept it. We need to know the reasoning behind it. For example, we need to know where it's sourced and is it trusted? Is it from a governing financial standards body or is it from an opinion on Twitter? A real example here is if a bank's AI denies a loan and can only say, well, the algorithm said so, that's not acceptable for the customer or the regulator. The impact on AI without explainability is that you get a lack of trust and audibility. Another example is if a medical AI makes a diagnosis and the doctor must be able to verify the process. In short, if we can't look inside the black box, we can't correct its mistakes or trust it with human lives. Fairness is perhaps one of the most urgent issues today. It asks the model, is the model perpetuating or amplifying human biases? An AI is only as fair as the data it's trained on. If the data overrepresents one group, the AI will naturally favor that group. In this example, if an AI facial recognition is trained primarily on light-skinned faces, it becomes inherently worse at recognizing dark-skinned faces. This isn't technical; it's a social failure. So the impact on AI is it's an issue of amplified societal bias, an unfair model that can lead to real-world discrimination in hiring, policing, and healthcare. If data quality here means actively seeking diverse representative data. The last new dimension is security, but we mean more than just locking up a database here. With AI, the model itself becomes a security risk. It can lead to private data, it can leak the private data it was trained on. This is called a model inversion attack. A hacker tries to trick the AI into spitting out private credit card numbers, for example, or names it learned from. The impact on AI is data exposure and manipulation. Um, there are various techniques that you can use, such as differential privacy to inject noise into the training process, protecting the individual while preserving the overall pattern. So, what does that mean, injecting noise? For example, your private location. Think of it like a fuzzy border around your real location when reporting it to AI. The AI just needs to know general patterns. So 1,000 people visited this downtown district between 8 a.m. and 10 a.m. It does not need to know specific individuals such as John Smith at 123 Main Street at 8:05 a.m. It doesn't need that. By injecting noise, the system guarantees the data used by AI is precise enough to show an overall trend, the high volume of people downtown, but is too scrambled at the individual level to ever identify a person's house or personal routine. The result is the individual is protected and the AI model remains useful. So to wrap up, we started with covering the 6 foundations, still very relevant for AI. But in the age of AI decision making, we know we must move beyond the 6 to embrace the new ethical and operational pillars of AI quality. So explainability, knowing the why, where's it from, how did it make its decision, treating everyone equally, so the fairness aspect, and security, protecting that underlying data within the model. The future of AI, well, it's not just about building smarter models. I believe it's about building responsible ones. And that starts and ends with quality data. AI will increasingly be used to clean, validate, and manage our data pipelines, but we still have to be there to prove it. Ultimately, as AI becomes more autonomous, the human role shifts to government governance, oversight, and ethical training, making human expertise and quality data more critical than ever. Anyway, thank you for joining me. I hope this gave you a new perspective on why data quality is the most crucial and often overlooked element of the AI revolution.